time to get through my slides in time as well. Welcome. Thanks for being here. Thanks for joining me. This is my second time here at Cloud Native Summit. I enjoyed it so far. I hope you'll enjoy my talk. I'll be talking about Talos Linux, my experiences with it over the last 4-ish years. I'm running this in my home lab. I don't know if you've read my talk abstract. I'll be trying and break and bring back up my home lab later in the talk in a live demo. So fingers crossed that this goes all well. Yeah, so let's get started. I guess many of you are running Kubernetes or operating Kubernetes in one way or the other. So this question might feel a bit moot. What do we need for running Kubernetes? There's lots of things actually, because Kubernetes is layered, right? Depending on how you consume or operate Kubernetes, you need to think of bare metal, servers, networking appliances, operating systems, container runtimes, Kubernetes components. At the very least, you want to have a kubelet running, the API server, the scheduler, and the controller manager, maybe also kubeproxy and cloud controller managers, some other operators in the mix. So what this boils down to is you want this in the middle, Kubernetes. You want to manage Kubernetes, run things on top of Kubernetes, but you end up having to manage and firefight all the stuff around it, right? Container runtimes, kernel patches, operating systems. So most, or at least some of those points might be familiar to you, what your day-to-day work might look like. You are being tasked with operating system updates, CVE patches, some of which might require some kernel tweaks or configurations, disabling kernel modules and stuff like that. You need to take care of user management, who's allowed to do what on your Kubernetes nodes, what users exist, should they exist. You need to take care of Kubernetes upgrades, hopefully in a timely manner, to get all those nice little features there. Static pod configuration, come to think of the API server, for example, which you might want to tweak for OIDC support or what have you. Static pod configuration and hardening, of course, because Kubernetes out of the box is nice, but is not as secure as you might probably want it to be. Yeah, so maybe you, like me, have been at the point where you reached out for tools to help you with that, right? Provisioning the infrastructure to run Kubernetes on with Terraform or OpenTofu, configuring your clusters with Ansible or Kubespray, which builds on top of it, using bespoke Kubernetes distributions like K0s or K3s, which promise you an easy and smooth day-to-day operations of the whole thing. And many, many more tools. There's an abundant list of tools. You might know the CNCF landscape meme, just go and look there. So yeah, I found myself very, very fast in a situation where I was like, isn't there a simpler way? There needs to be a simpler way, right? It's Kubernetes. It's basically a solved problem. It's not an easy problem, but it's more or less solved in 2026. It's stable. In a few versions, we can even roll back, I've heard. So there should be a simpler way. But before I get to that, a few words about myself. I'm Daniel Bodky. I work as a senior platform advocate at Netways Web Services. We're a small German cloud provider based in Nuremberg, so 2 hours north from here. My main interests at work and also in my free time when it comes to IT and cloud native related topics are Kubernetes, of course. I also meddle a bit in observability. I'm a Grafana champion. And GitOps. At home, I use Flux. At work, we use Argo CD, so I know my way around both of those established solutions. And of course, like probably some of you as well, I run a home lab at home. And this runs on top of Kubernetes, which means I also ran into all the production nightmares that come with running Kubernetes at home. And yeah, this leads us to Talos, the headliner of my talk. And this is taken right from the documentation. Talos Linux is a Kubernetes-optimized Linux distro. It does one thing, and it does it better than any general-purpose Linux distribution. That's a very bold claim. So how does Talos back this claim up? It does so by pointing out its 4 strengths. Talos is minimal, it's immutable, it's secure, and it's declarative. And at the first, very short definition from Talos again, what this means is the OS image is less than 80 megabytes in size, very small indeed. You can run it at the edge, you can easily update because downloads don't take that long, and stuff like that. It's immutable, as in it runs from a squashfs image. Operating system upgrades are written to a separate boot partition and just swapped in place and easily rolled back as well due to that fact. All writes go to ephemeral partitions. They're throwaway, more or less. It's secure. There's no SSH. There's no concept of a shell even in Talos Linux. All communication with the operating system happens through MTLS encrypted APIs. So it's a key-based communication. And it's declarative, as in everything is configured through a single YAML file. Please don't run away now. We all have our traumata due to YAML. But it is manageable because it's patchable and you don't have to write all of it all the time, all by yourself. I'll get to that later because those are still bold claims, right? So let's check against these claims a bit more thoroughly. And let's start with the minimalism aspect. So how is Talos packaged and distributed? I already mentioned Talos is a container optimized OS, even more so a Kubernetes optimized OS. It does nothing else. It's not meant to do anything else. It's not based on another Linux distribution. So if you think of or heard of distros like Flatcar or BottleRocket OS, which are container optimized and perfect for Kubernetes, they are normally based on top of another distribution. Talos is not. They take a minimally tweaked Linux kernel, pretty much vanilla, and build the whole user space from scratch in Golang. It's theirs. It's open source, but it's not built on any other project. It's available for very many different scenarios. That's why I initially started using it at home, because they support a wide range of single board computers. Think Raspberry Pis, Banana Pis, in my case, Turing RK1s. And you can consume all those images from their factory, which I want to show quickly because this will become relevant later on. You can self-host this as well, because under the hood, it's just a build service which builds your boot images. And from this selection, you can basically choose what kind of flavor you want. So if you want to run this in a cloud, you get images for all the hyperscalers, DigitalOcean. If you will run your own private cloud on OpenStack, you can get images for that out of the box, Hetzner, and so on. And as I mentioned, for my use case or any other homelabber or edge compute specialist out there, there's also a wide range of single board computers supported by the vendor. So no community forks or meddling with images and kernel configurations and whatnot to make it run. They support this out of the box, and I think that's pretty cool. So I will have to pick this image whenever I want to upgrade, but more on that later. Back to topic. So that's the minimalism aspect. It's purpose-built by themselves, not built on anything else, very small. What about the immutability aspect? There are dedicated partitions for almost everything. EFI, BIOS, boot might be quite normal also for other distributions, but then they split writes and where data lives into 3 other partitions called meta, state, and ephemeral. And at the root of it all is a read-only file system based on SquashFS that's mounted into memory as a loop device. And whenever you need to write anything, or the system itself needs to write something when it comes up, think host entries, so stuff like that. It does so in bind mounts that are recreated on each boot based on your declarative configuration. So it's immutable all the way through. And of course, there's the possibility to make data persistent across reboots. For example, if you use local storage in your Kubernetes workloads or etcd in your cluster, which of course needs to rewrite persistent data to the nodes where it's running on. This is based on overlayFS and backed by XFS as a file system. So with this 3-tier layout, you get like down to the file immutability unless you really need to have this specific file writable, which is quite neat in my opinion as well. Let's move on to the third claim they did, security. I already mentioned it. There's no SSH, no shell. Communication happens exclusively via an API and the CLI the Talos project provides. The services within Talos itself are wired through gRPC. So if the components of your Talos nodes need to talk to each other, that's gRPC based. There's no passwords at all. All authentication happens through MTLS. And the whole system, due to that fact and the very shallow user space, comes with less than 50 binaries. So your attack surface is quite low, I would say. And just for the fun of it, I ran through this practice and I actually counted the binaries. This was done like 4 weeks ago on a quite up-to-date Talos system. You can see here there's all in all 42 binaries on my control plane node. That's not that many, and half of those roughly are due to XFS being needed to provide writable and persistent storage in some way. So yeah, I think that's a good look for an operating system you only want to run Kubernetes on and not anything else. The last claim, the declarative model, I'll get into this in a bit more detail later on because this is probably the most interesting part. How do I configure this? What does it look like if I configure an operating system and Kubernetes at the same time? It all boils down to a single YAML manifest, which you can then extend through strategic merge patches. So you can regenerate the configuration, the base configuration, declaratively pinned to Talos and Kubernetes versions so you don't get any unexpected drift over time, and then just apply the same patches which you check into Git. You can do this in CI to get a declarative outcome which will always stay the same. And I listed some things here you can configure this way, things like disks and partitions on your nodes in case you plug in some external, some additional hard disks, for example. The versions of your Kubernetes components, Kubernetes feature gates. I will show this later in my demonstrations, in my live demo. You can tweak your container runtime configuration. Talos comes with containerd, and also things like static Kubernetes manifests and many, many, many more. So yeah, let's move on to the CLI because this is how Talos operates, but it still needs to be operated by us, the operators. And this happens exclusively through the CLI, starting with bootstrapping and initial configuration of your clusters, and then day-to-day work, think upgrades, updating, debugging things if a node goes south, stuff like that. And for this purpose, Talos control comes with around 50 commandlets, so like subcommands. You really should learn how to find your way around this CLI because it's bread and butter if you work with Talos. But it comes with commandlets for anything you might need, I would say. There's a bootstrap command, apply configuration, upgrade Kubernetes for upgrading the nodes and Kubernetes on top of it. There are troubleshooting and debugging commands like status health debug, which works the same as kubectl debug, so it spawns an ephemeral container on the system. Logs, pcap, and also system level insights into memory, stats, usage of disk usage, interactive dashboards that Talos provides, and things like that. So this entirely CLI-based interaction with Talos makes it very easy to automate things, for example, updates of Kubernetes or the operating system, or to have certain operations being run in CI/CD. Or by agents. This is 2026, right? I need to put AI buzzwords in here when you do like automatic root cause analysis or stuff like that. Pretty cool if you ask me. I'm a bit of a fanboy, so please bear with me for just 17 more minutes, then it's all over. So yeah, now let's move on to the basics. Common administration tasks. What do you normally want to do with Kubernetes? And for this is the exact slide I opened this talk with, maybe you remember. So how does this look like with Talos in place? How do I do OS updates? I run Talos control upgrade. How do I fix CVE patches? Well, probably we will get a lot less CVEs that affect us to begin with because of Talos Slim architecture. If there are some, sometimes remediation might look a bit different because, for example, you can't just disable a kernel module on the fly. You need to do so by configuring it in your configuration, rolling that out, and so on. So this is one point where you need to be a bit wary if it comes to that. Kernel configuration, performance tuning, things like that, you can do so by applying a new version of your configuration. User management, not needed. There is no concept of a user in Talos. There is role-based access control in the certification-based authentication authorization stack, though. Kubernetes upgrades, a single command, Talos control upgrade Kubernetes. It will upgrade your whole cluster one after the other in the best practice way. I've got a recording of that later on. Static pod configuration, again, just apply a new version of your config. And hardening, the same again. If you want to harden your Kubernetes following best practices, tweaking pod security admission, I will show this in a live demo later as well, just apply a new version of the config. So this might be a bit hard to have an image of in your head. So this is where I would start my live demos. For the first one, this is a jump host in our cloud because I can't stand up yet another cluster in my home lab. I ran out of hardware recently. So what do I have here? I got 3 worker nodes. We will only use 2 of those now, and I've got a control plane node. I've got the Talos control CLI installed here and kubecontrol to interact with it later. So if I want to stand up a cluster, each cluster needs some secret data, right? Think of tokens, think of all the data that needs to be used for generating certificates, both for Kubernetes and for Talos. So the first command I normally want to issue is Talos control gen secrets. This takes a moment. And then I got a single YAML file, which I can put in my HashiCorp vault or my secret manager, KeyPass, whatever you're using, because this will be needed whenever you want to generate configuration, which is the next step. I will now generate the base configuration with the secrets I just created in a separate step. And there I need to provide two values. Value 1 is the cluster name, and value 2 is the endpoint I want to be able to reach my Kubernetes API later on, because the configuration of the API server, for example, and also the certificates for the API server needs to know that. So let's use the control plane IP for that on port 6443. I mistyped. Nope. Like this. You can see it generated PKI and tokens, put them into the respective configurations where needed. And it also created a Talos config, which is Talos CLI's equivalent to a kube config. So we can take a look at that. Let's look at the config first. You can see very similar. It has a context. It has endpoints, which I can hit when I use the specific context. And it comes with a key and certificate needed to authenticate against this Talos cluster. Let's take a quick look at the control plane configuration just for good manners. We can see here there's a version, same as Kubernetes Talos versions its API and thus its YAML manifest as well. Then there's just a whole lot of configuration with all the documentation inline as well. So you can just generate the base config, start reading through when you get started with Talos, and you will know exactly more or less what you want to do. So for example, here you can see the control plane endpoint, which I provided when generating the configuration and the cluster name as well. And I could go on and do additional configuration here now. However, let's bootstrap the cluster. When I boot a Talos node for the first time, it goes into maintenance mode and is awaiting insecure communication because there's no MTLS setup yet, where I can push configuration once. So I can initially apply this configuration in the insecure way by targeting a node, for example, the control plane, and providing the configuration I want to apply, which is also the control plane config in this case. This applied already, and I will do the same now for the worker nodes. Let's do it like this. Worker 1 and worker 2. This should have worked out. I can now target, I now need to provide an endpoint because Talos clusters its internal API, so you need to go through an endpoint, which is normally a control plane node, and it will then reroute your API request, for example, to worker nodes. So if I target now the control plane and bring up the dashboard, this is now already, I need to configure my config first. Config merge. There we go. Okay. Yeah, so now we can see the live dashboard, and we see that the control plane already started bringing up some stuff. It's pulling images based on our configuration. Apparently, we are running Kubernetes version 136 right now. And to bring up the cluster, initially now I need to issue Talos control bootstrap, again, against the control plane. And then we can just sit and watch. Maybe I'll bring up the dashboard again. All the error loggings in here are expected. Those will go away in a few seconds. And while this is running through, I'll move ahead a bit and show you two other common workflows, because this will take 2 to 3 minutes now. This is basically the same I showed you right now. OS upgrades. I don't know if this is readable, but it's just 13 seconds, so what the hell. Upgrades in Kubernetes, I fetch the image I want from the image factory I showed you earlier and just provide this one command. It will cordon the node, drain the node, update and reboot, uncordon the node, all on its own. So in a Kubernetes best practice-y way, it will make sure the node workloads on the node get evicted if possible and rescheduled before updating and rebooting. And that's the whole process. And for Kubernetes upgrades, this looks similar. So what we do here is we upgrade the whole cluster at the same time. And I can stop this for a second. I don't know if this is readable. But it automatically detects the actually running Kubernetes versions and checks if this is compatible with the one I want to upgrade to. And then it starts upgrading the control plane node, which is detected up here. We can see here by the IPs, it pre-pulls all the needed images for Kubernetes components and then starts upgrading them one by one. Once this is done, it will go on and do the same for the worker nodes one by one. So again, this follows like Kubernetes best practice. If you look up the Kubernetes documentation on upgrading Kubernetes on nodes, it follows basically this workflow just in a fully automated way for your whole cluster. We can see here where it checks if the new version of the Kubernetes components has come up. And although skipped entries here in the bottom is Talos control checking the Kubernetes manifest it deploys itself against new API versions if there needs to be some updating done or anything. We can see here in the results, 1 second, yes, we can see here the version now is 136 for all of our nodes, and the Kubernetes components that got updated had recent updates. They're running for a few seconds there, but they are healthy again, running, and all this due to one CLI command. And this is scalable to basically infinity because Talos control will upgrade one node at a time, but will eventually have upgraded your whole cluster for you automatically. So again, I think that's quite neat. Let's take a look if the cluster I provisioned here has come up. I can do so by getting a kubeconfig from my control plane node. And can check if the nodes are healthy. That looks good. So we can see this is up for a minute now. Let's run an Nginx pod. Oh, never mind, muscle memory. Yeah, okay, so we see here, Talos comes with pod security admission enabled by default for all namespaces except kube system. So we get this warning. The pod gets scheduled though. So it's not like it's not running at all. And because I'm a bit short on time, I want to show you the other demo. You just have to trust me on this. If I apply this patch here, you can see I target the cluster API server admission control configuration within this document and tell it to exempt the default namespace from its current pod admission security configuration. I would be able to deploy the same pod without any warnings plopping up. Yeah, but I promised you in my talk title, reset, don't debug, reset. And that's what I want to spend the next 3 to 4 minutes on before I end my talk. With Talos, this is basically what your disaster recovery looks like. If a node becomes unresponsive or you manage to misconfigure kubelet or the container runtime or anything else on a node in a way that makes it very hard to recover, if the Talos API is still working, just reset the node with Talos control reset. If it's a control plane node, Talos will normally automatically offboard it from etcd, reboot it, wipe all system data except for the image that is on it at the time, and then you can just re-add it with the configuration you hopefully saved in Git and will come back online. If the Talos API is not working anymore, then of course you need to do a bit more of manual cleanup. You need to delete the node object in the Kubernetes API. You need to offboard the, if it's a control plane member, you need to offboard it from etcd yourself. And then you need to provision a new node and apply the configuration to that one. But still, that's quite simple. And that's what I want to show you. And this is now running in my home lab. I can show you here. This is my home lab domain. This is a cluster running there. I've got 3 nodes. All of them are control planes. So I get API high availability. And I use this cluster to run Ceph as a storage backend for basically everything I run at home. So this is actually production data on there. And let's pretend node 3 is unhealthy. So I'll just go ahead and say reset. I need to pass on one more argument, true. So what this will do is it will wipe the specified partitions. I can't wipe everything because a single board computer, if I wipe everything, it will not come back up anymore. I would have to flash it again. I set this graceful to false on purpose so I can show you what offboarding an etcd member looks like, because this is a control plane node. And I'll just shoot this. Still, Talos will try to stop and evict all pods on the node. We should be able to see this. We also see that through the Kubernetes API, Talos marked this node as scheduling disabled and not ready. You can also see that the pods get evicted and are now pending because they would come up on the API object, which is still there instantaneously. And now it's already rebooting, so I can go ahead and delete the API object here. And I can go ahead and say, members means like this. Yeah, so it's still a member of the etcd cluster as far as the other nodes are concerned. So what I do now is I get the ID of the node I just deleted and say Talos control etcd remove member, target one of the other nodes of the etcd cluster, pass the ID, and it's not a member anymore. And because this is my home lab, I've got lots of YAML running around. You see I have multiple tiers of patches here, but the resulting configuration I want to apply once the node is back online, yes, is this one, talos3.yaml. So what I do now is I run talos control, apply config, insecure, target the node I just deleted. It came up with the same IP, and tell it to use this one. And then we can watch how it will come back up in a few seconds. Normally the etcd member comes up fastest. Yep, it's already back in the etcd cluster. It's still a learner, so it's still catching up on all the progress, right? It's already back up in the API again. And because I'm very short on time, I will do my conclusions and will then prove to you that Ceph is coming back up on the nodes as well. Yeah, takeaways, what to remember from this and those pretty chaotic demos, I guess. There are 5 things you need to note down when you work with Talos. That's the cluster name and the cluster endpoint, because you need to provide those 2 information if you really go ahead and recreate the configuration from scratch and just apply your patches, which is the suggested way. You will need to save your secrets.yaml. You can, of course, rotate those secrets as well. And you should always pin the Kubernetes and Talos version when generating configuration, because otherwise you might get config drift. Treat your version patches as configuration artifacts. Throw away everything else you generated after you applied it to your node. You won't need it. Yeah, and before the first incident, you just saw a few of the commands I used with Talos control. There's many, many more. Understand Talos control, learn what it can do, learn what Talos control debug can do, what it can't do. Really make sure your machine configs and patches and patch order are documented. They are your single source of truth as Talos, as it regards Talos. And understand what Talos does not do on its own in some cases, things like removing etcd memberships or Kubernetes updates and cordons and drains in some situations, which you might have to do manually. Yeah, with that, thank you very much. I uploaded my slides. I'm also in the process of documenting my home lab publicly, and I've got a few how-tos, especially on upgrading, updating, removing, resetting nodes at this link on my website. And I also link to the official docs here. There's feedback via Sessionize. I think both the organizers and I would be very happy if you provided feedback. And with that, I got a few more seconds, so let's check if Ceph is coming back up. Looks good. No pending pods, no crashing pods. It's still initializing some stuff, but it's in the process of coming back on. Yeah, here's yeah, the observability stack's already working. This is probably the OSD. Yeah, the OSD is already back up as well. So Ceph is in the process of recovering as well. Thank you very much. I don't think we have time for questions, but I'm around all day. I'll wait outside of the room if you have questions right away. And yeah, thanks for being here.